Okay. Hi, my name is Anaid Torres Palacios, and I'm going to do and to explain how to do a basic circuit on Tinkercad. So for this basic circuit, we're gonna need three basic components. That's going to be 9 voltage battery, resistor, and a LED. So our 9V battery, it's going to serve as our power source here. It's going to provide the voltage to all the circuit. Now the resistor is going to ensure that the current passing through the LED it's good and it's appropriate not to blow the LED or yeah, just to blow it. Now our LED here it's going to serve as our visual indicator to know if all the circuit is well do. So now to drag our Navy battery here, you just have to click it and put it on the workspace here. This name is going to be 3. You can rotate it with this button over here to whatever you want. And because in this circuit we want to see good the difference and how to connect each pole to another and don't have it cross another. We're just going to put our positive pole at the bottom, at the top, and our negative pole at the bottom. So how we're gonna do that? We're gonna click over here in this mirror component. And now we have our positive pole at the top and our negative pole at the bottom. So we already have our 9V battery. Now we're gonna drag the resistor to the workspace as well as we did with the battery. We're gonna name it 2. And the maximum that the LED can support is 20 mA. So here on our resistance we need 417 ohms. These are the ohms here. Now we already have it configured to do it well. We're gonna rotate it in an horizontal way here to connect it well and to the positive pole and then through the LED. We're gonna put it right here. And now we need the LED. Last but not least, the LED. We're gonna put it right here. Now we can change its color to whatever of these: green, yellow, orange, blue, or white. And for this example, we're gonna need it in green. So we already changed it on green. And now what we're going to proceed is, or now we already have our components here, we are going to connect the positive pole through the resistance and the LED. And then the negative pole to the LED too. This is the cathode and the anode. The positive pole is going to be connected to the anode, and the negative one is going to be connected to the cathode. So, and now these little squares that appear over here, it's called pins. That it's basically saying us what are we going to connect and what are we clicking on it. So we just going to click on it. You can change the direction of your cable if you want to go to a straight line, or if you want to go, give a little turn over here and then to connect it over here. You can change this if you want to be on a straight line. Now we already have connected the positive pole to the resistor, this terminal 2. Now we're gonna put it the terminal 1, give a little turn over here to connect it to the anode of the LED. And now that it is connected, we already have the positive pole. And what happens if we don't connect the negative pole? Well, basically we click on the start simulation, it doesn't work. So we need the negative pole connected, yes or yes. So now we're going to proceed to the negative one, give a little turn over here and over here, and connected to the cathode. Now we already have the two of them connected. To see the difference of which cable is which, we're going to change the color to what the color is here on the battery. So basically, we're gonna change this to red, and the negative one, we're gonna put it on black. So now we see what is our positive cable and our negative cable. And now to finish, we're gonna click on Start Simulation. And what we see here is that the LED is at its bright, at its maximum bright, without exploding. And what happened if we change this? We're gonna eliminate this zero. This is what happens when you don't configure well your resistor. So what basically happens is that the LED explode. And here is say that the current through to the LED is 20 mA, while the absolute maximum is 20 mA. So yeah, we exceed the maximum, so that's why we need 470 ohms to work well. And that is all for this. Thank you.